Chord of contacts. Well, first of all, let's define what a chord of contact is. So, once again, our standard parabola. Now, a chord of contact is, we have seen that when we draw from an external point, it's possible to draw in two tangents. And so we would know the coordinates of this point. I'd say some random coordinates, x0, y0. Okay. From that external point, we can draw in two tangents, which would meet, again, don't know the actual coordinates. I'll give it the parameter p, and the other one, parameter q. The chord that joins those 2 points, that's what we call the chord of contact. So it's the chord that joins the 2 points of contact where the two tangents meet from the external point. So the question is, of course, what is the equation of that particular chord? I mean, earlier we saw how to find the equation of any general chord, but what about this one in particular? Going to look at two different ways we could approach this question. So with parameters, and you may or may not remember, but when we looked at chords, we could go and show that PQ had the equation P plus QX minus 2Y equal to 2APQ. So just the general equation of a chord. Now we could also find the equations of those two tangents. So PX minus Y minus AP squared and QX minus Y minus AQ squared. We could solve them simultaneously and come up with our point of intersection, which you remember for two tangents was A times the sum of the two parameters for the x value, A times the product of the parameters for the y value. However, we know that external point. We know it is x0, y0, whatever they happen to be. So therefore, I can rewrite P plus Q, because x0 must be A times P plus Q. So the sum of the parameters for this particular problem must be whatever that x value of the external point is, divided by A, the focal length. And y0 would be A times PQ, so I could rearrange that one as well. So all right, let's go back to the equation of the chord. We just said P plus Q is now x0 on A, so I can sub that in. And 2APQ, well hang on, we said APQ is y0. So remember, PQ with just these two random points, we don't know what they are, but we've managed to get rid of those parameters, but introduce the fact that we do know, that being the coordinates of the external point. And so we can come up with our equation of a chord, which often we rewrite it like so. Again, look at the structure of the actual equation. x0 x equals 2a y0 plus y. Exactly the same as the equation of a tangent. Difference being, with the equation of the tangent, the x, well I think we called it x1, y1, with the tangent. But that's a point that was on the parabola, and that allowed us to find the equation of the tangent. With chord of contact, this x0, y0 is a point that is not on the parabola, and we're finding the equation of the chord that joins the two tangents. But the actual structure of the line is exactly the same. And again, it has similarity to the equation of the curve itself, x squared equals 4ay. Okay? So notice, similarity tangent. All right, Cartesian approach. If I was using the Cartesian approach, I could show the equation of the tangent, PT. Remember, we got it to look like the curve. So x1 is 2a y plus y1. Now, I know the point T lies on PT. So if I substitute x0, y0 in, I come up with a correct statement. So it must be true that x0, x1 is equal to 2a, y0 plus y1. Therefore, x1, y1 must lie on this line. x0 x equals 2a, y0 plus y. As I say, it looks dodgy. Let me explain. I know the structure of a line. A straight line is something that has the equation some constant times x, some constant times y, and then it may or may not have just a constant by itself. This x0 x equals 2a y0 plus y. I've got a constant times x. I've got a constant times, a constant times y, and then I have a constant by itself. So that is definitely the equation of a line. If x1 lies on that line, then when I substitute it in, I should get a correct statement. But if we look at the line before, I do. Because this t lies on pt, therefore x0, x1 is no different to me saying, substitute x1, y1 into x0, x and so on. So I know that is the equation of a line. And I know x1, y1 satisfies that equation. Therefore, x1, y1 does in fact lie on that particular line.
Is PT the chord set?
PT is the tangent. Okay, I could do the same thing with QT, the other tangent. QT would end up having equation x2 plus 2ay plus y2. But again, t lies on qt, so that must be a correct statement. So q also lies on this line, x0 x equals 2a y0 plus y. Well, if q lies on the line and p lies on the line, then the equation of the line PQ must be that line. So hence, there's your chord of contact. So I suppose the hard thing with this is more the explanation of how we get there. It looks like, as I say, it looks like we haven't done any maths at all. All we've done is written down the equations and things and gone, oh look, it works. Anyway, see how we go. 9H. Again, a handful of chord of contact questions.